27 to the power x plus 64 to the power x upon 48 to the power x plus 36 to the power x is equal to 193 upon 144. We have to find the values for x. Now 27 we can write it as 3 times 3 then whole to the power x plus 64 as 4 to the power 3 then whole to the power x upon 48 as 4 times 4 times 3 then whole to the power x plus 36 as 3 times 3 times 4 then whole to the power x is equal to 193 upon 144. Now when a to the power m whole to the power n is equal to a to the power m times n, this we can also write it as a to the power n whole to the power m. Therefore this can be written as 3 to the power x whole to the power 3 plus 4 to the power x whole to the power 3 upon, now let's consider 3 to the power x is equal to m and 4 to the power x is equal to n. Then we have m cube plus n cube upon m square n plus n square m is equal to 193 upon 144. Now m cube plus n cube, it is in the form of the algebraic expression a cube plus b cube, and this we can expand as a plus b times a square minus ab plus b square. So this we can write it as m plus n then times m square minus mn plus n square upon, here we can take mn common and write mn times m plus n in the bracket is equal to 193 upon 144. Now these two are like factors, so we can cancel. Now we have m square minus mn plus n square upon mn is equal to 193 upon 144. Now mn is the common denominator, so we can write m square upon mn minus mn upon mn plus n square upon mn is equal to 193 upon 144. Now here we have mn, this gets cancelled, 1 here minus 1 plus n upon m is equal to 193 upon 144. Now we add 1 to both sides, we have mn plus nm is equal to 193 upon 144 plus 1, or mn m upon n plus n upon m is equal to 193 plus 144 upon 144. Now let's consider m upon n is equal to a. In that case we have a plus 1 upon a, because n upon m is the reciprocal of m upon n, is equal to 337 upon 144. We multiply 144 to both the sides. This 144 gets cancelled. We have, or 144, here it is a square plus 1 upon a is equal to 337, or 144 a square plus 144, this a to the right hand side, it will be 337a. Now change the side, now we have 144a square minus 337a plus 144 is equal to 0. This is a quadratic equation that we can factorize. We need to find two numbers whose product is equal to 144 times 144 and whose sum should be equal to 337. Now if we factorize 144, 12 times 12 is 144. This also 12 times 12. Now 12 is 4 times 3. Now if we multiply 4 times 4 is 16, 16 times 4 is 64, and 64 times 4 is 256, and we multiply all the 3's. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. If we add 256 plus 81, it is equal to 337, and if we multiply 256 times 81, it will be equal to 144 times 144. Therefore, we can factorize it as 144a square minus 256a minus 81a plus 144 is equal to 0. Or we can take here 16a common and write 16 times 9 is 144, so 9a minus 16 times 16 is 256, minus, again here we can take 9 common and write 9a minus 16 is equal to 0. Now 9a minus 16 is common, so 16a minus 9 is equal to 0. Now we have two solutions for a. When 9a minus 16 is equal to 0, in that case 9a is equal to 16, or a is equal to 16 upon 9. And when 16a minus 9 is equal to 0, in that case 16a is equal to 9, or a is equal to 9 upon 16. Now we considered a is equal to m upon n. So when a is equal to 16 upon 9, then m upon n is equal to 16 upon 9. Again, m is equal to 3 to the power x, and n is equal to 4 to the power x. So we have 3 to the power x upon 4 to the power x is equal to 16 upon 9. Or we can write it as 3 upon 4 whole to the power x is equal to 16 as 4 square upon 9 as 3 square, or 3 upon 4 whole to the power x is equal to 4 upon 3 whole to the power 2, or 3 upon 4 whole to the power x is equal to, we can write it in the form of negative exponent. So we can write it as 3 upon 4 whole to the power of minus 2. Negative exponent means multiplicative inverse of the base. Now bases are same. If a to the power m is equal to a to the power n, and a is not equal to 0 or 1, here a is 3 upon 4, then m is equal to n. In that case, x is equal to minus 2. So this is one solution. When a is equal to 9 upon 16, so 9 upon 16 is equal to m upon n, and m is 3 to the power x and n is 4 to the power x. So 3 upon 4 whole to the power x is equal to 3 upon 4 whole to the power 2. Therefore, x is equal to 2. So two solutions for x are x is equal to 2 and x is equal to minus 2. So two solutions for x are x is equal to minus 2 and x is equal to 2. How did you solve it? Let me know in the comment section. Thanks for watching.